right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump into it. We are plotting the first in terms of each sequence, stating whether the graphical evidence suggests that the sequence converges or diverges. On the last one, 21, I just kind of like did it all in Desmos. This one I want to do by hand because it's really, really similar to 21, but there's like a little bit of a difference to this one, and I think we'll see what that is in a second. And I just figured because it's really close to the other one had a lot of square roots. If you're trying to put it all in Desmos, it's like a square root of a square root of a square root. So let's look at what that would actually look like if we did it by hand and look at how we could maybe simplify some of those square roots. Because Desmos, not that great at like keeping things in radical form. Some calculators are, like the Casio equivalent of a TI-84. Is actually really good at keeping things in radical form all on its own. You can make programs for the 84 that that'll simplify radicals for you, but it's just a lot more. It's just easier to do it on a Casio. And I don't know about higher levels of 80 after 84 for TI, but let's go ahead and look at it because you might have to do one of these by hand. So we're gonna look at a couple different values. So we'll start at n equals 1, which is 1, and then 2, which is 2, and then 3, which is 3. And then from there, we kind of just have to do the math. So I think I'll probably just stick with one column because I have a feeling like it'll get a little complicated as we go here. So a sub 4 is equal to the square root of, and then it would be a sub the previous term times a sub the previous term times a sub the previous term. And that's just going to be the square root of 6. Right, so 4 and then the square root of 6. That's not going to simplify. All right, well, what would it be if we were looking for a5? What's the square root of the previous term times the one before that times the one before that? So this one's going to be a little different. This is going to be the square root of 6 root 6, which is like the square root of, this would be like 6 to the 1 and 6 to the 1/2. So it'd be 6 to the 3/2 power. And then another square root, so that's going to be 6 to the 3/4 power, or the 4th root of 6 cubed. So actually, you know what? Let's go ahead and write them as fractional powers. I think that might be easier as we move forward here. So 6 to the 1/2 power, and then 6 to the 3/4 power. Because I think we might end up with some sort of pattern with 6s. At least so far we have 6s going on here. So let's see. A6 square root of the previous term times the one before that times the one before that. Okay, this time it looks like we're not getting another 6. We've got a 3. The 2 times before that it was 3 times 2, so we had a 6 in there. This one's just a 3, so I don't know. Let's see. We couldn't really write that as a power of 6. We could kind of simplify some of this other stuff, but that's going to kind of throw a wrench into things, actually. That would be 6 to the 3/4 times 6 to the 1/2. I could add those. 1/2 is 2/4. So then that would be 6 to the power times, probably add the power. So 3 plus 2 is 5, so that'd be 5/4. But then it's times 3. Okay. I mean, you could split up the 6 into 2 and 3. So like 2 to the 5/4 times 3 to the 5/4. And you could do it that way. And then you can combine the 3's, but then you would have the 2's separated. So you're kind of just back where you started. It's not really any more simplified if we did it that way. But we could split it a little bit. So that would be 6 to the 5/4 to the 1/2, which would be 6 to the 10/8. No, what am I doing? 5/8. 5/8. But then there's also that square root of 3. So 3 to the 1/2 power. Okay, kind of a weird number, but it is what it is. So 6 to the 5/8 and 3 to the 1/2. All right, and we'll probably end with a to the 7th because that's about all I'll have space for, I think. A to the 7th, so we take the square root of, and it's the previous term, which is that and that. That's supposed to be a 5/8. The previous term, and then the one before that, 6 3/4, and then the one before that, 6 1/2. Okay, lots of different 6's here, so I would add 5/8, 3/4, and a half add up to 5/8. That's how we got there in the first place. Actually, no, they don't. Just kidding. They add up to 5/4. So that's 6 to the 5/4 plus 5/8. So then that would be 5/4 would be 10/8, and then 10 and 5 make 15, so 15/8. So the square root of 6 to the 15/8. And then we have that 3 still, 3 1/2. All right, so then that's going to be 6, and then we have 15/8, but I'm going to take half, so 15/16, and 3 1/4, because I'm taking half of a half again. So the 7th term is going to be 6 15/16, and 3 to the 1/4. Okay, so it looks like it's going to keep doing that. Like we're going to keep getting like base 6's and base 3's as we go forward here. It was looking like we were only going to have base 6's, but then we ended up with that base 3 there as well. So base 3 and base 2 if you were to split up the 6. So we've got base 3 and base 2, which kind of makes sense because the first 3 terms were 3, 2, and 1. So, you know, the square root of 1 is just 1, so it's the square root of 3 and the square root of 2. So you have base 3, base 2 raised to ever-changing powers. The 6 went from 1/2 to 3/4 to 5/8 to 15/16. So it looks like well, if we split the 6 up into 3 and 2, then it would have been 3 to the 15/16, and then you have 3 to the 1/4, and that would be a little bit more than, that would be like 3 to the power of something a little more than 1. So something that's a little bit more than 3. And then you'd have the 2 to the 15/16, which is about 2 to the first power, which would be about 2. So 2 times, and then it's 3 to like a little bit larger power. I don't know if this one's actually leveling off though, because ultimately we're timesing 3 numbers, but we're only taking the square root. On the previous one, I'm pretty sure that that one is converging. It was just timesing by a sub in -1 and a sub in -2. So you're timesing 2 things, but then you're taking the square root. It's like a geometric, it's like geometric rounding, like arithmetic, or not rounding, a geometric average. So a geometric average is different from an arithmetic average. The regular average or the arithmetic average, you add 2 numbers, divide by 2. Okay, or if you added 3 numbers, then you would divide by 3. The geometric average would be if you times 2 numbers, then you would take the square root. But if you were to times 3 numbers, you'd take the cube root. And so this one, this particular problem, 22, is not quite the geometric average of 3 numbers. It's a little more than that. So I think this one might be divergent just based on that kind of intuition alone. We could play out a couple more iterations and see what happens. We got Desmos pulled up over here. And I can cross that out, because that was from the previous problem. And let's take a look. So let's put this over here maybe. And we'll put in some of these values. So we've got 1 1, and we've got 2, 2, and we've got 3, 3. And we'll do maybe like 5 values at a time here. So the next one is, we said it was 4 and the square root of 6. I'm just going to write them as powers. I think that's going to be easier. 6 to the 1/2 power. There's 4 values. And then the 5th value is 5. And then we've got 6 to the 3/4 power. 6 to the 3/4, nope, 3/4 power. Okay, so there's the first 5 values. Now, let's see, so 6, and then it's, where are we at? Oh, there we are. Okay, so 6 to the 5/8, 6 to the 5/8 times 3 to the 1/2. Okay, so we've got that. And so look, it keeps increasing little bit by little bit here. It does look like it's diverging away, whereas the other one didn't look like it was doing that. The next one, let's see if we can maybe, so it would be the square root of the 2 previous terms. So let's see if we can find a way to do that real quick. Oh wait, we already have 7. What am I doing? So 7 is, and that's 6 to the 15/16, 15/16 times 3 to the 1/4. Okay. Then next we would have basically the square root of the 3 previous terms, right? So square root of this. So copy paste that times, and then the one before that. So there's the previous term. Here's the previous term. So we want to copy paste that one. Copy. And then right after that, put that one. So that's 2 previous terms now. Oh, nope, 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 nope. I was trying to scroll with the trackpad, but it is not like that. 1, 2, and then we would go to this guy to get my third. So 8 would use 7, 6, and 5. So that's just 6 to the 3/4. I'll just type that in manually. 6 to the 3/4. 6 to the 3/4. So times 6 to the 3/4. And now we've got the previous 3 terms all put in there. Okay. Oh, it looks like I already had the closing parentheses. All right, cool. So there's that. And let's see what this looks like. So actually, I'm going to maximize this. So let's see. Yeah. Yeah, so it's definitely going up. Definitely seems to be the trend there. So you have those first 3 values, and it kind of dropped off after that a little bit. So it did go down a little bit, but then, so those first 3 values were just kind of like the established values, and they could have been any 3 things. But the pattern that occurs after you have those established first 3 values looks like it's basically, I mean, it looks like it's almost a straight line. It looks like it's got a slight upward curve to it. But yeah, that's definitely going in the up and over direction. So that's going to be diverging away. It's not going to be leveling off and going horizontal anytime soon. And I think it'll continue to go in that pattern. It looks like, if anything, it kind of goes in the upward direction, more up than over. And not just by slope, but I mean like the curvature. It looks like it's curving up, as in it has a positive acceleration to it, not just a positive slope. Which, you know, even more so reason to think that it would it'd be diverging away. So hopefully that is helpful. And I know it says to do the first 30, but once you kind of get the gist of it, it's like, all right, like the rest of it is just tedious work of actually, doing all the math there. So I said this on the last few, pretty much all of them, all the ones that are in this set where the directions are plot the blah 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 blah. But I'll say it again for this one. If you want to see me do the explicit formula to help get all of the values really quickly, just let me know. That's something I can do. It's just something that I have to think about. It's not something that you need in order to solve the problem, so it kind of wasn't like a priority to do that. But it is a little tedious finding out every single value by hand, going all the way to 30. So finding the explicit formula would definitely be saving some time. So let me know if you think that would be helpful, if that's something you want to see. And yeah, just throw it in the comments below, or you can shoot me an email if you want. I have my email down below. Because if anybody has any questions about like tutoring or anything, you can shoot me an email about that. You can also see answers to those kinds of questions on my website, as well as my free guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. And that's in the description down below as well, myersmathematics.com. So go check it out. And hopefully there's a lot of goodies in there that are helpful to you. So I'll catch you in the next video. Blessings, y'all.